Hello students, welcome to lecture 10 of chemical equilibrium. Next topic, effect of temperature change. In previous lecture we discussed about effect of pressure change. Now in this lecture our topic is effect of temperature change. If we change the temperature, the value of equilibrium constant Kc will be affected. In exothermic reactions, the equilibrium constant Kc decreases with increase in the temperature. In exothermic reactions, the equilibrium constant Kc will be decreases with the increase in temperature. Exothermic reactions means the reactions in which heat is released called exothermic reaction. And in that exothermic reaction, the delta H is negative. The change in enthalpy is negative. So in exothermic reactions, the equilibrium constant Kc will be decreases with increase in temperature. So in exothermic reaction, Kc is inversely proportional to the temperature. And in endothermic reactions, the Kc will be increases. Equilibrium constant Kc will be increases with the increase in temperature. Endothermic reactions means the reaction in which heat is observed called endothermic reaction. So in endothermic reaction, Kc is directly proportional to the temperature. The equilibrium constant Kc will be increases with the increase in temperature. Let me take one example, production of ammonia. Production of ammonia is a exothermic reaction. Let me take that reaction. So the production of ammonia, N2 gas plus H2 gas equilibrium NH3 gas. And delta H is equal to minus 92.38 kilojoule per mole. Means the delta H is negative. So it is a exothermic reaction. And the equilibrium constant Kc is equal to concentration of products divided by concentration of reactants. So here the production of ammonia is a exothermic reaction. According to Le Chatelier's principle, increase the temperature, equilibrium shifts to left, means backward direction. Means what I am doing here, first of all, this reaction is at equilibrium and this reaction is an exothermic reaction. The heat is released and I increase the temperature of that reaction. Then what happening? The equilibrium will be disturbed. To get a new equilibrium constant, the reaction moves in backward direction. Backward direction means here product to reactants. Then the concentration of ammonia will be decreases. So high temperature is not favorable for production of ammonia. Low temperature is favorable for high yield of ammonia. But very low temperature slow down the reaction. To prevent it, catalyst is used to increase rate of reaction and yield of ammonia. So in exothermic reaction, if you increase the temperature, the equilibrium shifts to backward direction. In exothermic reaction, if we increase the temperature, the equilibrium shifts towards backward direction, and it is opposite to the endothermic reaction. If you increase the temperature in endothermic reaction, the equilibrium shifts towards forward direction. This is about effect of temperature change. And next one, effect of temperature experiment. Let us take one experiment to prove that there is a effect of temperature on equilibrium. Effect of temperature experiment in exothermic reactions. Let me take one reaction. Here, brown color NO2 gas dimerizes into colorless N2O4 gas. NO2 gas is brown color and N2O4 gas is colorless. And this reaction is a exothermic reaction. Delta H is equal to minus 57.2 kilojoule per mole. So the delta H is negative. So it is a exothermic reaction. Here I am taking two test tubes. In these two test tubes I am taking NO2 gas. And they are sealed. And these two test tubes having the same intensity brown color due to NO2 gas. The NO2 gas gives brown color. Here I am taking 3 beakers and each beaker at different temperatures. Beaker 1, in that beaker 1 I am taking a freezing mixer. Means in this beaker 1 I am taking the ice. At temperature 270 Kelvin means minus 3 degree centigrade. In beaker 2 I am taking a normal water, that water at room temperature. Here I am taking water and the temperature is 298 Kelvin or 25 degree centigrade. And in beaker 3 I am taking hot water and the temperature at 363 Kelvin or 90 degree centigrade. So these three beakers are at different temperature, and in these two test tubes I am taking NO2 gas and these two test tubes having same intensity brown color. First of all, I placed these two test tubes in beaker 2, means at 25 degree centigrade, and after some time the intensity of brown color remains constant in the test tube, means equilibrium does not disturb. The intensity remains constant because the intensity of brown color remains constant. And after this experiment I take out these two test tubes from the beaker 2 and one test tube placed in beaker 1. And other one placed in beaker 3. The beaker 1 at low temperature, that is minus 3 degree centigrade, and beaker 3 at high temperature, that is 90 degree centigrade. Let me label these two test tubes as A test tube and B test tube. I take out that A test tube from beaker 2 and I put it in beaker 1. In the same way, I take out that test tube B from the beaker 2 and I put it in beaker 3. After some time, the intensity of brown color decreases in test tube A, which is placed in beaker 1, because it is placed at low temperature. So here brown color decreases means the concentration of NO2 gas decreases, or the concentration of N2O4 gas increases, because it is colorless and it is brown color. So here the equilibrium constant Kc is equal to product concentration, N2O4 concentration divided by reactants concentration, NO2 concentration. Means here in beaker 1, intensity of brown color decreases, means the concentration of N2O4 gas increases, means the product concentration increases. So here the product concentration increases, means the Kc value increases. So here the Kc is greater than Qc. Consequently, at low temperature, forward direction is favored. Forward direction is favored. Forward means reactants to product. So in beaker 1, the forward direction is favored because the beaker 1 is at low temperature, and after some time the intensity of brown color increases in beaker 3. So the beaker 3 at high temperature 90 degree centigrade. In beaker 3, intensity of brown color increases, means the concentration of NO2 gas increases, means reactants concentration increases. If we come to the equilibrium constant, so Kc is equal to products concentration divided by reactants concentration. In beaker 3, reactants concentration increases, means the Kc value decreases, because the denominator value increases, then the Kc value decreases. So in beaker 3, means at high temperature, the Kc is less than Qc at high temperature. At high temperature, backward direction is favored. Backward direction means products to reactants. So in beaker 3, the backward direction is favored because the beaker 3 at high temperature, and in beaker 2 the forward direction is favored because the beaker 2 at low temperature. So these changes in exothermic reactions. Let us take in endothermic reactions. Next one, in endothermic reactions. What happening in endothermic reactions when we change the temperature? Let me take one example. So here it is a endothermic reaction. Hexa aqua cobalt 3 complex ion aqueous medium plus 4Cl minus aqueous equilibrium hexachloro cobaltate 2 complex ion aqueous plus 6H2O liquid plus delta H, means the delta H is positive, so it is a endothermic reaction. And here this complex is in pink color and Cl minus in aqueous colorless, and this complex is in blue color. At room temperature, this reaction is in equilibrium, and this reaction mixture is blue color due to hexachlorocobaltate 2 complex ions. So at room temperature, the reaction mixer is blue color. If we cool the mixer, means decrease the temperature, equilibrium will disturbed. Then the equilibrium re-established by backward direction and color changes to pink due to hexa aqua cobalt 3 complex. So at room temperature, the reaction at equilibrium and the reaction mixer color is blue due to this complex. And if we decrease the temperature, the equilibrium will disturbed. Then the equilibrium re-established by backward direction. Product to reactant means the color changes from blue to pink. So if you decrease the temperature in exothermic reaction, the equilibrium shifts to forward direction. But in endothermic reactions, if you decrease the temperature, the equilibrium shifts to backward direction. So these are effect of temperature experiments in exothermic reactions and in endothermic reactions. Let us take summary in exothermic reactions. Number 1, decrease the temperature. Decrease the temperature means cooling. Favored forward direction. Favored forward direction. Means reactants to products. And second one, increase the temperature means heating. Favored backward direction. Means products to reactants. And in endothermic reactions, number 1, if you decrease the temperature means cooling. Favored backward direction. Means products to reactants. And second one, if you increase the temperature means heating. Favored forward direction. Means reactants to products. This is the summary of effect of temperature change in equilibrium.